Hi, today I'm going to be explaining how to invert first a 2x2 matrix and then a 3x3 matrix. Inverting a 2x2 matrix is relatively simple compared to a 3x3, involving fewer and easier steps. Given a matrix M equals A, B, C, and D, to find the inverse, first we must find something called the determinant of the matrix. The determinant M of a 2x2 matrix is given by AD minus BC. And it gives an area scale factor for the transformation base represented by the matrix M. So if this M represents transformation, then the area scale factor of that transformation is given by this value, det M, which is AD minus BC. To find the inverse then, M minus 1, we perform the following. 1 over det M multiplied by a transposed matrix. So what we do is we swap these two and we make both of these negative. So we end up with D minus B minus C and A. And now this is a matrix, this is a scalar, so we just multiply the scalar into each element in the matrix to find the inverse. I'm trying this with real numbers. So let A equal 5 minus 7, 2, and minus 9. We find that the determinant of A is equal to AD, so minus 9 times 5 minus BC, 2 times minus 7. We end up with minus 45 plus 14, which is equal to minus 31. So A minus 1, or the inverse of our 2x2 matrix A, is given by 1 divided by minus 31, because that's the determinant of A, multiplied by a transposed matrix. So we swap these two. So instead we write minus 9 and 5. And these two are both multiplied by minus 1. So it's positive 7 and minus 2. Now, because this is a scalar, we just multiply this by each element in the matrix. We find that A minus 1 is given by 9 over 31 minus 7 over 31, 2 over 31, and minus 5 over 31. So that's how you find the inverse of a 2x2 matrix. Now, moving on to 3x3 matrices, our first step is to form a matrix of minors. So let M, a 3x3 matrix, be such that, well, let a matrix M be A, B, C, D, E, F, G, H, I. Every element of this matrix, so A, B, C, D, E, F, G, H, I, every single element has something called a minor, which we find by crossing out its row and its column first. So let's say we have little a over here. The minor of little a is represented by big A, and we find that by crossing out this line, because they're both associated with A, and we are left with E, F, H, I. Now what we do is find the determinant of E, F, H, I, or in the notation, you have two long lines and then E, F, H, I. This represents the determinant of this section. And this is equal to this, which is equal to the minor of A, which is given by capital A. So what we have to do is for every single element in this matrix, we have to find the minor. So take, for example, let me just rewrite this. take, for example, E. If we want to find the minor of E, this line goes through E, and this line goes through E, and the remaining elements are A, C, G, and I. And so you find the determinant of this, treating it as a 2 by 2 matrix, which would mean E equals minor of E equals AI minus CG, because AD minus these two multiplied in terms of the 2 by 2 matrix. So what we have to do is we must form a matrix of minors. That's our first step to finding the inverse. And what you end up with is A, B, C, D, E, F, G, H, I. It's quite a lot of effort to do that for each element. But once you do that, you are left with this matrix of minors where every element is the minor of its corresponding element in the initial matrix M 3 by 3. So now we have this, we want to form a matrix of cofactors. So what we do is we have a checkerboard pattern like this. So we have this element, this element, this element, this element. Each one we multiply by -1. That's it. So in a checkerboard pattern, we just multiply the elements by -1, which isn't too hard. And that gives us our matrix of cofactors. Now we adjugate the matrix by transposing all of its elements. Those are some fancy words. Basically, we pretend like we draw a line y equals -x through the middle of the matrix, and we reflect the matrix in that line. So M transpose. So we have a matrix of minors, and our matrix of cofactors, because we multiplied everything by -1. And what we do is each element is reflected in this line. Obviously, the ones on the line stay there. So we end up with A, E, and I. These stay the same. Now, -b and -d are flipped because they're on opposite sides in this line of symmetry which we're reflecting in. G and C are also swapped, and -h and -f are swapped. So you should have, I rewrote that as it was before when I shouldn't have. A minus D, G, minus B, E, minus H, and C minus F and I is the matrix transpose that you should be left with. Now, we need to find the determinant of this 3 by 3 matrix. How we do that is given by, det M equals AA minus BB plus CC. So here, if we look at our top row in our initial matrix, we have the elements A, B, and C, and their minors are given by big A, big B, and big C, or capital. Our determinant is given by A multiplied by its minor, minus B multiplied by its minor, plus C multiplied by its minor. Now, I believe this can be done with the second and third row too, if we follow the checkerboard pattern and invert the numbers. So it should be minus DD plus EE minus FF, and so on with this one, flipping it back. But when in doubt, stick to this original one, because this is the main one you need to remember. These are just side ones. But that should give the determinant of the matrix M. It gives a scalar. And to find the inverse, M minus 1 of our initial 3 by 3 matrix is given by 1 over det M multiplied by the matrix transposed. So writing this out in full, if we have a matrix given by, to summarize, for a 3x3 matrix, A, B, C, D, E, F, G, H, I, the inverse is given by 1 over A minus B plus C, where this represents the determinant of the matrix, multiplied by A minus D, G minus B, E minus H, C minus F, I, where each of these elements is a minor of one of these initial elements. And that's how you invert a 3x3 matrix.